Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my BEng Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at the 2014 question. It was the sunflowers question. John is given two sunflower plants. One plant is 16 centimeters high and the other is 24 centimeters high. John measures the height of each plant at the same time every day for a week. He notes that the 16 centimeter plant grows 4 centimeters every day, and the 24 centimeter plant grows 3.5 centimeters every day. Draw up a table showing the heights of the two plants each day for the week, starting on the day that John got them. Okay, so I have a couple of pieces already done. I just created this table here, which is the days of the week. So we have to measure their heights for a week. Okay, so that's my 7 days. I've just called the plants Plant A and Plant B. You can call them Plant 1 and Plant 2, whatever you want. And I've included this day 0 column, okay, because the plants didn't start off at 0, they started off at a height, okay, so before we start measuring them for the space of a week, they are already at a height, okay. So a good way of describing that is what we call their height on day 0, and day 0 being from today. Okay, and the other thing I noted down was that the 16 centimeter plant, which I called Plant A, is +4. It's growing 4 each day, and Plant B, which was the 24 one, is growing +3.5 each day. Okay, so yes, you could create a formula and put it into a calculator, but it's actually easier just to go 16 plus 4 is 20, plus 4 is 24, plus 4 is 28, 32, 36, 40, and 44. Okay, so that's the fastest way of doing it. It's a bit harder to count up in 3.5s. 24, 25, 26, 27.5. 31, 34.5, 38, 41.5, 45, 48.5. Okay. So that's draw up a table showing the heights of the two plants each day for a week, starting on the day that John got them. Okay. So that was part A. Part B then is a type of question that an awful lot of students struggle with. It's more of an algebra question where you have to go from words to equations. So write down two formulas, one for each plant, to represent the heights of the two plants on any given day. State clearly the meaning of any letters used in your formula. So I can call it anything I want. I just have to explain what it is. Okay. So I'm going to say Plant A equals. Okay. So you want your height on any given day. So in other words, what did I do to go from here to here? Okay, well, I added on 4, but I added on 4 to what? Okay, so the first bit is, where are you starting? I'm starting at 16 and I'm adding on 4. Okay, so that's the pattern to get from here to here. Now, how do I get from, let me just mark it in maybe orange. So that's a +4, okay? To get from day 2 to day 3 is another +4, or from the start, from my 16, can you see it's a +8, okay? Which is the same as 2 times 4. And it's 2 times 4 because I have 2 days growth. On day 3, I would have 3 times 4. Okay, so this 4 bit is common. Okay, and that's the plus 4 that's going on here. But what I need to do is multiply it by d, which is however many days growth that you want to add on. Okay, so to test it, let's just pick d equal to the sixth day. And I just randomly picked 6. 4 6s are 24, 34, 40. Okay, and I do indeed get 40. Okay, so you can leave the test there if you wish, or you can rub it out, it doesn't matter. You can just do that test on your calculator if you want, where plant A is height and D is equal to number of days growing. Or phrase it something like that. Okay, and then once you've one of them, it's much easier then to see the other one. So plant B is going to be the same thinking, except this one I'm starting at 24. I'm going up by 3.5 every day. Okay, where plant B is the height of the second flower, and D is equal to number of days growth. Or again, whatever way you want to phrase it. So this is a piece that an awful lot of people struggle with. Okay, the next part then asks you to draw the graph. Right, so doing out the graph, the first thing I noticed is over the first 4 weeks, so not over just the first week that we have drawn here, okay? So first 4 weeks. So we know at day 0, we're 16. I'll just take the first one first. At day 7, I'm going up in weeks here now. At day 7, I'm 44. At day 14, I would be, let me use my formula. So into my calculator, I'm going 16 plus 4 times 28. So 128. No, day 14, sorry, I did day 28 there. I would be 72. At day 21, I would be 16 plus 4 times 21, 100. And at day 28, I would be, where did I get my 28? There's 28 days in 4 weeks, 128. Okay, so that's the first flower. And the second flower at day 0, I would be 24. At day 7, I would be 48.5. At day 14, for this one, I would be 24 plus 3.5 times 14, 73. At day 21, for that flower, I would be 3.5 times 21, 97.5. And at day 28, I would be 122. Okay, so 4 weeks. I've just picked weeks, going up in weeks. Okay, and I got these values from our formulas that we created a while ago. Okay, so that's what I need to plot. So let's make a graph. Okay, so I need to go up to 128. So what? I think it makes sense to go up in tens. Okay, so 10, 20. I'm just going to go every second box now. 40, 60, 80, 100, 120, 140. Yeah, I'm up high enough. Okay, then across the bottom, yeah, let's go up in 7 days. So let's see, do I have enough boxes? I would need 28 boxes. There's no way there's 28 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No. So let's go 5 boxes for each number. Okay, and it doesn't matter. It doesn't matter how many boxes. You just look at the space that's available to you and you try and spread out your graph as much as you want, okay? So you try and make the most of the area you have. But the only thing is you have to keep 1, 2, 3, 4. You have to keep the widths the same. So see the way I'm going over in 5 boxes here, I have to go over in 5 boxes for them all. So 1, 2, 3, 4, 5. Brings me to 14, 1, 2, 3, 4, 5, brings me to 21, 1, 2, 3, 4, 5, brings me to 28, okay? Just the same as when I was on the y-axis, I was going up in tens per box, and so that's 10, that's 20, and it would have got too cluttery if I'd written in all the numbers. So I only wrote in every second number, but I skipped 2 boxes, so I could still have 30 there, I still have 50. So I'm still only going up in 10 for every box. I just haven't written them all in. Okay, so then we plot. So I'm going to plot in black and blue. That's why I wrote the numbers like that underneath it. So plant A, as we call him, and day 0, he was 16, which is somewhere here. Okay, day 7, he's 44, which is somewhere here. Day 14 is 72. Halfway is 70. Day 21 is 100. And day 28 is 128, which is almost 130. Okay, and actually the easiest ones to plot between are the 16 at the start and the 100, because that was bang on a box. And you just join them together. Okay, so that's my plant A, just to link it back to my last question. Okay, or to, I suppose, to the table that I drew. And of course, you could put in all the points along here on all the different days. That's no problem at all. I'm putting them in here, but they're just going to follow that line. So to draw a line, you really do only need 2 points. I would have been perfectly fine taking the 16 and taking the 128 at the end and just drawing a line between them. Strictly speaking, I don't need to work out all of these, okay? But that does show the examiner that you know what you're doing when it comes to this, and therefore you'll get the most of the marks, just in case you did make a mistake calculating day 28. Okay, so let's switch to blue then and do plant B, or whatever you choose to call them. So halfway up there, that looks somewhere like 24. Day 7 is 48.5. Day 14 is 73, kind of on top of each other. Day 21 is 97. And day 28 is 122. Okay, and let me try and draw them together. Obviously now yours on paper is going to look a lot better than my one does on a digital screen, because it doesn't allow me to be that accurate. But it's good enough to show you the concept of what the question should be. Okay, so John assumes the plants will continue to grow. Draw graphs to represent the height of the 2 points over the first 4 weeks. Okay, so the sun, I never explained, I did call it the sunflowers question. The sunflower question is probably known because it's quite a difficult question and it's a long question, okay? So the sunflowers question. So you can see there, when I look at that graph, remember in the last question I was talking about being able to read graphs, I can see that plant B starts off the highest, the tallest plant, but after a month, after 28 days, the other plant has overtaken it, okay? And that would make sense because plant A is growing by 4 centimeters a day. So at some stage it is going to overtake plant B. Okay, and you can see, more importantly, I labelled the two lines, the two graphs, plant A and plant B, or whatever you chose to call them here. Okay, but give them a title of some sort rather than not call them anything at all. And in general, the questions will give you a name to go by. It's unusual that they didn't in this case, but if you don't have anything here in your original one, just invent something. And plant 1, plant 2, small plant, big plant, whatever you want to call it, it doesn't matter, just as long as you keep the consistency throughout the question. Okay, from your diagram, write down the point of intersection of the two graphs. Okay, so where do they cross? And you could see on mine, because the lines are so thick, it's quite hard to tell. We are all going to get different answers for this. So if yours is quite different from mine, I don't actually have the official solutions here, but I'm going to say that it is somewhere here in the middle. And I imagine you'll have a different answer, okay? So construction lines on the graph are really important. I might make them a bit thicker so you can see them, okay? Because that again shows the examiner you know how to read a graph. So from your diagram, write down the point of intersection from the two graphs, okay? So it's always x comma y when we're writing down a point. It's no different here, even though it feels a bit strange. So I'm getting somewhere between 14 and 21 days. Looks a bit closer to 14, so 15, 16, 17 days, I'm going to say. So 17 comma, what's my height? 80. Okay, so yes, most of the marks go for these construction marks on your graph. Explain what the point of intersection means with respect to the two plants. You should also refer to the meaning of both coordinates. Okay, so what does it mean? Well, at this point, both plants are the same height. Okay, that's what a point of intersection means. They're the same something. Okay, now it says refer to the meaning of both coordinates. Okay, so the 17 means what? And I didn't label my axis. That was a bit naughty. So that's days. This is height. Okay, you should always label your X and Y axis. This occurs on day 17. Okay, the plants are both 80 centimeters on this day, or something to that effect, that explains that you know the 80 means a height, you know the 17 means days and days growth. Check your answer to D part 1 using your formulas from part B. Okay, so our formulas from part B, plant A. Now I'm not expecting this to work. 16 plus 4 times D. Okay, so I'm saying that on day 17, it should be about a height of 80. Okay, so let's try it. 16 plus 4 times 17. So if I put that into my calculator, not too bad. I got 84. Okay, so I can see now that really it should occur on day 16 because one day less if I could draw it down here, and I would be that height of 80. Okay, so if you got something like 1680, you're probably a lot closer than I am. Okay, plant B was 24 plus 3.5 times D. Okay, so that's 24 plus 3.5 times 17. Let's see what we get for that. 83.5. Okay, and again, if I was one day less reading off my graph, I would have been more accurate. Okay, but that's how you do that, and that's how it all links together. Okay, if I was in an exam and I could see I'm a bit big, I would go back and change my 17 to 16 because now I know that that's what it should be. Okay. The point of intersection can be found either by reading the graph, which is what we did, or by using algebra. State one advantage of finding it using algebra. Okay, well, algebra is the most accurate method of finding the point of intersection, okay? Because you're solving formula and there's no room for reading off a graph wrong or subbing in something wrong and so on and so forth. Okay, how would I do it with algebra? Well, I would say plant. I'll just set it up. We won't be doing it, but I'll just set it up is equal to 16 plus 4d, and this one was equal to 24 plus 3.5d. Okay, so you'd end up solving it using simultaneous equations normally. Okay, and these two would be h, something like that. Okay, and you'd cancel one of the letters and you'd end up solving it. Okay, so that's how you would do it with algebra, and that is a very, very common question in a lot of chapters, including functions, where you have to find the point of intersection off the graph and you might have to verify it using algebra, okay, or using simultaneous equations. Part G then, this was the last part in this question. John's model for the growth of the plants might not be correct. State one limitation of the model that might affect the point of intersection and its interpretation, okay? So the last part of a question, not always very mathsy, and this is one case of that. So why is his model not correct? Well, if you think common sense wise, does a plant grow at the same rate every single day for 28 days? No, it just might stop growing. You might forget to feed it, you might forget to water it, or it just might naturally not grow at the same rate every day. Okay, and of course then that's going to affect the heights of either plant. State one limitation. John's model assumes constant growth or the same growth every day. This does not normally occur in the natural world. And if you think not so much adults, but children growing, you've often heard of a growth spurt. Well, during a growth spurt, you grow much more than you do normally, okay? So in the natural world, things don't grow at the same rate all the time.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.